Hello everyone. Good evening to all of you. Can you please confirm me, am I audible or not? Hello everyone. Now I'm going to start about the course. It is data structures and algorithms using Python. Okay, so first of all, I'll tell you about the course, what we are going to cover in this training. Basically, in this training, we are going to cover data structures and algorithm using the Python. Let me show you the course content. You can visit our website www.goeduhub.com and there is a link. You can see over that. You can see here the course content. We will send you in the chat window also, and here you can see the complete course content. So don't worry guys, this is 45 days course and we are going to cover lots of things. We are going to cover each and everything from very scratch to expert level. First of all, my way of teaching is I'll cover the basic topic and the concept behind the topic, and then I'll tell you the implementation part. So this is the 100% practical oriented course, and you know DSA is the basic course for a programmer. If you are belonging from a computer science background or if you are belonging from the other branches also, this is very important part of the course of your curriculum, because this makes the base. What is the data structure basically? Basically, data structure is the base for storing the data in the memory. So if you are a programmer, you cannot be a good programmer without knowing the data structures. Okay, so in this course, we are going to cover these 10 units. You can see here the content. We start from the very basic introduction and analysis of algorithms, then searching algorithms. We are going to cover linear search, binary search. Then we are moving ahead the sorting algorithms like bubble sort, insertion sort, selection sort, merge sort, quick sort, countings, radix, heap sort, and then we will go to the very important and the linked list. Linked list is the best topic of the interviews. Like everybody, favorite topic in the interviews, like everybody asks the question about the linked list in interviews. Like I never have seen anything, any interview in which they are not asking about the linked list or not asking about the data structures. If you are going to face any interview that is related to core companies, like if you want to enter inside the development and implementation part in any good company like Google, Facebook, Yahoo, then you will face the questions related to data structures. Okay, and in the linked list, we are going to cover different type of linked list, different operations over the linked list like insertion, deletion, then reverse the linked list, then the doubly linked list, then the middle of the linked list. We can append the different items, we can remove the items, we can do the different tasks over the singly linked list and then the doubly linked list. And then we have different another type of linked list, that is the circular linked list. And then we will see the stacks and queues, that are the very basic topic, basic data structures in the programming. And we will see the priority queue, we will see the trees, we will see the binary trees, B trees, different type of trees and complete programs for the trees. We will implement all the programming part in the Python. Okay. So an arrays, basic data structure, graphs, and then the most advanced part of data structure is dynamic programming, divide and conquer algorithms. So we will do the practical part in dynamic programming also. So this is the basic course content. I have just introduced to you about the course content which we are going to cover during the 45 days. And guys, one more thing, the implementation part, we will cover the Python. So in the coding part, you should know in the Python, we will cover basics like list and all these things in the Python, how to do the programming in the Python. Meanwhile, with this course. And now come to the for today's class agenda, what I'm going to cover in today's class. Okay. So now come to the for today's class agenda, what we are going to cover in today's class. Okay. In the today's class, we are going to cover what is data structure, what is algorithms, why DSA is important for placements, even for the non-CSIT students, relationship between data structures and algorithm, what are the characteristics of algorithms, advantages of algorithm, disadvantages of algorithm, and how to design an algorithms. And one instruction for you guys, if you have any question, I don't want this class one way, I want interactive class. So if you have any question related, technical question related to this class, you can ask in the chat window. Meanwhile, after the in between the session, I will give you some time to ask your questions also, because it is difficult to answer in between the session. So if some questions are common, I'll address in between the session. Otherwise, I'll take some time during the session and I'll address your questions. Okay. So first question I ask you, can you tell me what is the data structure? Just write in the chat window. What is the data structure? What do you mean by the data structure? And your attendance related, your certificate related queries, you can take the answers. We have our Telegram channel. You will get the link of Telegram channel in the chat window. You guys can join that Telegram channel. Most of you already have there, so you will get the instructions there. Okay, I got some answers like what is data structure? It is a way of organizing data in a structured way. What is the structured way? You know structured way already. Some people writing the answer like storing data, organized in a structured way, and it is designing a structured program. Okay, good attempts, and some of you already have written the good answers. So let me tell you what is the data structure. Okay. Basically, data structure is one of the most fundamental subject in the computer science, Data structures is a particular way of organizing data in computer so that it can be used effectively. It is not a data type like integer, float, character that we have in the programming language. It is not any physical entity. It is basically a logical entity. It is not a memory, like something you are storing. It is just a specification, or you can say it is a set of rules that we provide so that data is stored in a particular way for efficient use and access. Or in simple words, I can say data structures are basic building blocks. So I'll open my pen. and I can tell you about the data structures. It is a basic building blocks. How it is a basic building blocks? Like if you are a software engineer, you are making a software program. So data structures are basic building block for a software program. One cannot become a good programmer without a sound understanding of data structure. You can take a simple example like you are building a home. We are building a home. Okay? We are building a home, and what the raw material we need? We need certain bricks, we need roads, we need clay rocks, we need sand, we need wooden parts and building materials. On top of that, you apply some instructions to building a home. And at the end, what you get? You get a home as a result. Let me open the article. Like you can see at our website, there are lots of articles. Like whatever I'm teaching you, you will get as a notes, as a part of this training with you. Like whatever I'm teaching you, you will get the notes also. This is the best part of this training. Like what is data structures and algorithm? You can see here is the article available in our website. So basically, when we are building our home, we getting these raw materials. And similarly, when you are building a software application, you need raw material blocks, which are basically your data structures, like array, linked list, tree, etc. And what we will do when we are making a program, on top of that, we will apply some code instructions, and which basically operates on those data structures. As a result, you get a software application. Like I can tell you here, a program, what we need? A program plus data structure, and at the end we will get a result that is a good software. And like you are a good programmer but you don't know about the data structures, you don't know the data structures, then your program can be a normal program, but it is not an efficient program. Efficient program means we are using minimal resources like processing power, memory, processing plus memory. Okay? So here, now I can say data structures are basic building blocks. Data structures, blocks. Okay? And what are the data structures we have? We have array, we have linked list, and we have queues, stacks. Okay? So use of right data structure for a problem, like I have taken an example of making home, and when we are making a window, if you start with the bricks, then you can't build a window. You should use the wooden material. Okay, so as a software engineer, your role is pick right data structure for right problem. Yes guys, you will get the recorded session after the classes. Okay, so I think you should clear with the data structure now. What is the data structure? We can take the another example, like I'm taking the another example of dictionary. Okay, in the dictionary, I just want to search a word education. I just want to search for a particular word education. There are thousands of words in the dictionary, even we don't know exact count of words, right? Every time new words are added. So I tell you search for a particular word education. Let's say how we will do. Just by looking over the word, we know that words start from E and EDU. So you know in the dictionary, you directly jump to the words start from ED and then you search for the word education. This is the possible because in the dictionary words are arranged in the alphabetical order A to Z. They are arranged in the A to Z. Just imagine these words are not arranged in a particular order. Any word is put anywhere. Then what happened? If they are not ordered, then what happened? How would you search for thousands of words in dictionary? It probably take hours to search for a particular word. Right? Are you agree with me? So since it is organized in a way, we can easily find it. That is the real world data structures emulate that in the digital world. How our data is organized with the help of data structures. Now you should clear with the concept. We can take the another examples also like you can take the example of library. When you go to your college library, you find a particular, you just want to search for the data structures book, you will go to the section of engineering section, then the data structure section, and there you will search for a particular author book, right? Most of the people are added to our Telegram group and some people have posted the link also there. So you guys please join the group and you will get all the instructions there. Here please focus on the class only. Now we will take a technical example here. Okay, I'll take a data structure example. These are the real world example I have taken. Here I'm taking, I'll just want to take the temperature of Delhi of last 5 days or 5 days of December. Okay? So my question is, like, I'm taking a list. L is equal to 8, 4, 8, then 6, 4, 2, and 1. These are the last 5 days temperature of a particular city I'm storing in a list. Now my first question is, what was the temperature on day 1? So question is, on day 1. Okay. And the second question is, what was the temperature on day 4? So here question number 2, what was temperature on day 3? Okay, so here you are caring about the sequence. So you can take a list, like I have taken a list, and you can simply access the elements. In the Python, we have list L is equal to 8, 6, 4, 2, 1. And I just want to access the elements of the list. I can access by their index. Index is 0, 1, 2, 3 and 4. Now, temperature of day 1. Temp of 0 would be temperature for day 1. Okay, and for the day 3, I just want to get the temperature for day 3 is temp 2. Similarly, now this is my simple requirement. I can just simply store these things in an array, a simple array, or if I talk about the Python array implementation, we will do with the help of list. Okay. Next thing is, I just want to ask you, I just want to store the temperature along with the dates. Like I just want to store the temperature for 1st of December, 2nd of December till the 5th of December. Then what I will do? In this case, I need a dictionary. I need to use the dictionary. Like here, temperature along dates. Okay, so what I will do here, I will save the temperature like this, temp in a dictionary. You know dictionary, don't worry about the Python basics guys, I'll cover each and everything. Just for the starting topics, just cooperate and you will get each and everything. Because these basic things I need to tell you. Otherwise, we cannot implement the data structures. You know, data structures is looking tough subject, but this is very easy subject. Okay, so I'm using here the dictionary, and inside the dictionary, I'm storing the values like December 1. For the December 1, I'm storing the temperature 8, and for the December 2, I'm storing the temperature 6, and so on. For the December 3, I'm storing the temperature 4, and similarly for the December 4, I'm storing the temperature 2, and December 5, I'm storing the temperature 1. This is my dictionary. Now, if I just want to access the temperature of December 4, then how can I access? I can access simply temp, and inside this I can write the key. So for the December 4, I can get the temperature on December 4. So I have used two different data structures to solve two different problems. One is list and another one is dictionary. Okay, which is dictionary is actually hash map. Behind the scene we are using the hash map in the dictionary. So we will see that later on. Okay. So I can tell you, we will see the memory layout, like how the data is stored inside the list and dictionary. Okay. So basically what I have done, I have taken two different data structures for the two different problems. Like if I know about the data structures, then by observing the problem, I can choose the best data structure. Best data structure I can choose if I have knowledge about the data structures. Okay, so that is the difference. Like you are sitting in an interview, and the interviewer basically focused on the data structures. Why? They want the person who are aware with all the tools, like which tool they choose for solving a particular problem. Like for the dictionary also, if you need to search a word in the dictionary, what would be your approach? Do you go page by page, or you open some page, or if the word is not found, you open the prior or later? So basically in the dictionary case, we search, we find, we choose the binary search. Like from a dictionary, I just want to search a word, education. Which searching algorithm I have to choose? Either linear search or binary search. Two things I have. I will choose the binary search. Why? Because if I'll choose the linear search, then it will take the long time. I need to go page by page. Every page I need to scan for a single word, and it will take lots of time. And what happened in the binary search? In the binary search, basically, what we will do, we will find a particular word. Like if I'm searching for the education, randomly I opened a word like text. If I got a word text, then what I will check? Text is after the education. So I will go prior the text. Prior or after. Again, if I got cat, then what I check? Cat is always coming prior to the education. So I will go after the cat. And then similarly, I'll process this thing, and in a finite time, I get my word education. Are you getting the things? And it reverse in the linear search, what I will do? I need to go by page. I need to search on every page. So binary search will take less time in case of dictionary. So this is the good example of choosing a right algorithm to solve a specific problem in less amount of time. There is the two things. One thing is we need to check the right data structure. I'll open a new. And two things we need to do. One is the right data structure. We need to choose the right data structure, and second thing is right algorithm. So I have covered both the things. Like right data structure we have taken in the case of temperature example. In the temperature example, we have taken two different data structures, and in case of dictionary search, we have taken the right algorithm. Similarly, you can take the another example, like you need to keep a deck of cards and arrange it properly. How would you do that? You will throw it randomly, or you will arrange the cards one over another and from a proper deck. You can use stack here. to make a proper arrangement of cards one over another. So in the case of to arrange a deck of cards, you need to choose stack data structure. So right data structure, we need to keep in mind which data structure we use for particular problem. So this first example is a good example of choosing the right data structure for the real world problem, and the second example is for choosing the right algorithm to solve a specific problem in less amount of time. So these examples will give you a clear understanding that how the organization of data is really important in our day-to-day life. Arranging data in specific structure is really helpful. It saves lots of time. Save time, save resources. And obviously, when you are working in a company always want a particular solution in less time using the less resources. Okay? So data structures importance is very important in real world. Now we will come to our next topic, that is what is the algorithms. Okay, now we are very much clear with the data structure. Now we will take the second problem. What is the algorithms? You guys please give me this answer. What is the algorithm? Okay. Yes, Mohit is asking a question. Does in Python you are going to cover the OOPS? Obviously, Mohit, we have to cover the OOPS because without the OOPS, we cannot implement data structures in Python. So for implementation of data structure in Python, we need to cover the OOPS. And Umesh is asking a question. Linear search will be the better instead of sorting elements because sorting will take n log n, and wherever linear search will take only the log n. It depends on the situation, what type of sorting you are doing, what type of things you are working. I'll tell you, just wait. In the analysis or performance of algorithm, I'll tell you which one is more better. Okay, I got lots of answers for the what is the algorithm. Basically, almost all of you given the right answer. It is a step-by-step procedure. It is a set of instructions. Okay. So let me define it. What is the algorithm? And one more thing I have left it, like different data structures you already know, like we have data structures array, hash table. So you can see arrays we can write like this, and linked list we have two childs. One is the node, one node, that one is the data, and second one is address for the another one, next one. And we have different in the different languages we have different way to implementation of data structures. Like for arrays in Python, I can implement array using the list. In Java, I can implement the array using native array or array list. And in C++, I can implement the array using native array or a standard vector. So I can write here also, like for the array implementation. In the Java, I can use two types of array, native array and array list. Array list is dynamic array. And in the Python, we have list to implement array. Okay, and similarly to implement the hash tables. In the Java, we have hash map. And in the Python, we have dictionary. Okay. And for the linked list, obviously for the linked list in the Python, we use the OOPS concepts. There is the no linked list available. In Java, we have linked list already available. Linked list class. So we will use the OOPS concept here. Okay, I hope it will give you the some understanding of data structures. Like there are the different ways to implement the different data structures in different languages. Okay, now come to the back. What is the algorithm? I was explaining you what is the algorithm. So basically, algorithm is step-by-step process. We use set of instructions. You can see this article, and it is a well-written article. What is the algorithm? It is a tool for solving a well-defined computational problem that takes one and more set of values input. Basically, I can write here, we have certain input, we have certain output. Like here input, and here I'll design an algorithm, and then I'll get some output, and here set of rules. Okay, so in the simple language I can say we have certain input, we have certain output, and we have certain rules. Okay, and now come to the technical language, that is the algorithm is step-by-step procedure for solving a problem by using a pseudocode. One question comes to my mind is, what is the difference between the function and algorithm? You guys must know. Yes, notes will be provided to you. You guys can access these notes anytime. Our website is available. Okay, so basically function is in the mathematical way, it have relations in between the variables, and in the computer science language I can say functions are a set of codes to save our time to do the redundant task. And whereas the algorithms are the precise, algorithms are not always have implementation. They have set of rules, but it's not necessary we implement in a particular language. We can write by them by your hand also. Okay, so simply you can say a function is a block of code in computer program, and algorithm is abstract concept. It describes how to solve a problem. Okay, now come to the pseudocode. What is the pseudocode? Pseudocode is an informal way when we want to write about the program. We don't want to implement the program directly, we just want to write certain lines. So for that we use the pseudocode. It is an informal or artificial language that helps programmers to develop an algorithm. Okay? And the advantages of algorithm is, what are the advantages? Basically, it is a step-by-step and it is easy to first develop an algorithm before implementation. Like when you are getting a problem from your boss, you are working in a company and you are getting a problem from your boss, and your boss says, complete this problem till the evening. What you will do? First analyze the problem, and then you will write certain steps to achieve that goal. These certain steps are your algorithm. Okay, so you will write a step-by-step procedure to implement your problem. It is a definite procedure. Now we will see some characteristics of a algorithm. How we can design an algorithm and what are the rules a algorithm should follow. Right? Guys, maybe this lecture is little bit theoretical, but after the characteristics of algorithm, I'll move towards the Python code. So we will do some Python code. Okay? So first see the characteristics of algorithm. Like first of all, algorithm should have certain steps, finite steps. It never enter inside an infinite loop. It always have finite number of steps. It always dominates. And second thing is definiteness. Each step of the algorithm must clear, means no ambiguity. Your steps should be clear. And it is simple, easy to understand to convert into a program statement. Suraj is asking a question, what is the difference between instruction and algorithms? Instruction is a single instruction. Algorithm having set of instructions. Okay? I think you should clear now. And generally, algorithm should run for any program. It should not fix. It never be like this. It is working for a particular program, but it is not working for the another program. Always algorithm is generic algorithms. And it always takes some inputs and it will produce some output. Like we are writing here an algorithm for adding two numbers. First we will write an algorithm, then we will write a Python program for this. Okay? So here we are adding two numbers. First we will start, then we will read two values. Okay? And then we will add two values, then store the result in another variable, then we will print the value of the variable that result contains. And finally we will stop. This is the simple algorithm. Very basic algorithm when we start coding. Like when you enter inside your college or even in the school also, when you start the coding, the simple algorithm you will write. I'm telling about the simple algorithm. I'm not telling about the data structures and algorithm. Okay, after the algorithm we will combine both the topic, what is the how data structures and algorithms are interrelated. Okay, so this is the simple algorithm I have written. Now I'll write a program. Now I'll tell you about the implementation part of the data structures, how we are going to implement. Some guys are asking which software we need to install and what we need to do the implementation. You don't need to install any software. We will do the each and everything online. What you need to do, just open your Google and just follow the steps along with me. Just open the Google and here search Google Collab. Okay. Google Collab is an environment that will provide you an editor to execute your Python code. Okay. Even it will have different libraries, advanced libraries like TensorFlow and Keras, all these things. We can implement artificial intelligence code also here. But for your use, you can say it is a simple Python editor. It is basically a GPU provided by the Google. You can use the Google GPU and you can execute your code and you don't need to worry about the installation part. That is none of your business. Okay, so basically what we will be doing, we open the Google Collab link and here you need to log into your Gmail account. If you are already logged in, you don't worry, it will open like this. Otherwise, it will ask you for sign in to your Google account. So here I'm already logged in. I'll open a new notebook. And here what will happen, you can save your code. Your code will be saved to your drive, so you can use that whenever you want and from anywhere. Like Today you are working at your home. After some time you will go to your college and you just want to enhance your code. Then what you will do, just open your Google account, open your Google Collab, and then you can edit that code. You will get your code anytime. You can use the Anaconda, you can use the PyCharm, you can use the other editors also. That's up to you, but it is the very easy, already ready to use. You can use that. It is a Google GPU. Either it have more capacity than your system, and you don't need to worry about the libraries installation also. It removes your hurdle of installing the libraries, each and everything. Like people who are working with the Google Colab, they love the Google Colab, and even I also mostly use the Google Colab. Otherwise, you can use the Anaconda also. Previously, I was used to use the Anaconda, but that is the little bit like heavy software. Okay. And so here, what I will write here, I'll just write a simple Python program. Okay. So here I'm writing a Python program to add two variables. You guys please do along with me. Okay. So what we will do, we will start here a is equal to 10. And in the Python, you know guys, we don't need to initialize, we don't need to write the semicolons. It is very simple language. It is just like an English language. You can simply write the variable, and then you can give the values, and then you can use the variables. Okay? Yes, you can use the Google Colab on your smartphone also. So you don't need to worry about the installation part. And you know, Google is providing you a GPU. Obviously, you should use that, right? A is equal to 10, B is equal to 20. So in our algorithm, there are the two steps. First, initialize the read two variables. I'm just fixing the two variables value, and then store add two variables. So here I'm taking the third variable result. Result is equal to a plus b. And then simply I'll print the result. And don't worry, some guys don't know about the Python. You will learn Python within the 10 days. And in our next course, that is the machine learning with Python, in which I'll cover Python from very basic. Here I'll cover the Python that is needed for the data structures, and in the next batch I'll cover each and every concept of the Python. So it's up to you. If you want to join the next batch also, you can join that also. A is equal to 10, B is equal to 20, result is equal to A plus B, and print result. Okay, so it's executing and we will get the result here. Here you can see the result. Result is equal to 30. So this is the simple implementation of a normal algorithm. Then we will do some coding part of the sorting algorithms, and we have lots of libraries in the Python. Like we have a math library, import math, and then we can use like different functions of the math library, math dot sqrt square root of a. Okay, x is equal to, and then I can print x, and you can see the output here. This is the simple how to import a library from the Python. Why it is taking too much time to execute? It depends on your internet speed, no? Little bit, it depends on your internet speed. If you have good speed, it will take very less time. Okay. Like here, I have imported a math library, and from a library, I'm using a function sqrt. Math dot square root of a and then print x. And how to take user input in the Python. Most of you already know, I think. This is the simple question, how to take the user input in the Python. So simply for taking a user input, a is equal to, there is a function called input. And inside the input, whatever I am writing, it will be written as it is. And enter the value for a. And you can see here, it is asking for a user input. Here I am putting the value 10. And you can see the output. You can print the a, and the value for a is 10. And the important thing, the interesting thing about the Python is, you can see 10 inside the single quotes. Okay? 10 inside the single quotes means it is taking a string by default. So what I need to do, I need to convert a string into the integers. Int. It's not a Python class. I'm little bit covering here. I'm not going to cover each and everything. Just for your understanding, I'm covering here. From the next class onwards, I'll do the implementation of DSA algorithms. Okay guys, so this is the simple part where we are going to do the implementation and in which language we are going to do the implementation. Now the question comes to your mind, why we are doing the implementation in Python? Why not we are doing implementation in C, C++ or in Java? This question must occur in your mind. The answer is, Python is most demanding language nowadays, and it is a very easy language. You can learn within the few days Python. You can implement code in the Python very quickly. Like obviously, if you are an engineering student, you must have studied the C programming. If you are good with the C, then you can implement in C also. If you are good with the Java, you can implement in Java also. It's your choice in which language you want to implement data structures. Data structures basically, it is a base for the programming. It's not depend on the programming in which language you are implementing. It's up to you, but most of the students nowadays, they are liking the Python, and Python is a future language. Okay? So it is easy to implement data structures in the Python. Nowadays, it is demanding. And you guys can easily, obviously, Umesh have written Python is an ocean of opportunities. Yes, Python have lots of things. And it is an open source language. You guys can, it is increasing its capacity. Day by day, people are adding more libraries in the Python. Okay, so now come back to our algorithms part. We have seen what is the algorithm. Similarly, if you want to write an algorithm for average of 3 numbers, you can write it easily, right? This is the simple algorithm for 3 numbers. Now come to the next part, how to do the simple analysis of an algorithm. This is very, very important. Okay, so basically algorithm analysis is very important, because how much time we are taking, how much resources we are taking, it depends on analysis of algorithm. If you know analysis of algorithm, then you can pick the right algorithm for the right problem. Let's assume if we have to move from a point A to point B, you have to move from Delhi to Jaipur or Delhi to Chennai, then there will be various ways to select your path. Like you just want to go by a bus, you want to go by an aeroplane, you want to go by a train. It will certainly depends on the destination. Whether the destination will be cities, we can travel via train. Destination between the houses, then we can travel via the bicycle also. And destination is Far away, we can travel via aeroplane. So similarly, in the data structures also, we can select various algorithm for same problem and various data structures. It depends on us which algorithm we are choosing. Two things we need to consider. One is the time complexity and another one is the space complexity. How much time a particular algorithm is taking and how much space a particular algorithm is taking. So we need to compare the different algorithm and then we will choose a particular algorithm. Okay, and today I'm not covering the complexities part. I'll just tell you the relation between algorithm and data structures. That is the interesting basic part you should know. Okay, so relation between data structure, algorithms and data structures. Relationship between data structures and algorithm. Now you know both things, what is the data structures and what is the algorithm. Now you can relate both things. Okay, you know algorithm is well defined set of rules, right? It is a like what rules we need to follow during a program. Algorithm is simple. We write certain steps, start, then we'll declare some variables and then we do some operations, then we will store our output, then we print output and then we stop it. Now come to the data structures. From the data structures point of view, data structures point of view, we have different type of algorithms. Like we have searching algorithms, we have sorting algorithms, we have insert algorithm, we have delete algorithms, and other one is, I'm forgetting some more, update also. So from the data structures point of view, we have different categories of algorithms. Basically, data structures are programming way of storing data. So algorithm, you can say, algorithm needs data structure. Data structure, right? And a program use both things. What is a program? A program use DS, data structure, as well as algorithm, right? Now you should clear with the program, algorithm and data structure. You can write a simple program that will follow certain data structure, that will use some data structure and follow certain rules. And there are the different data structures. We already know data structures. What are the data structures? We have different data structures like tree, graph, array, stack. We will cover each and every. Don't worry about it. Queue and all this. I remember all this. Maybe there could be some more. Okay, so now we are clear with the relationship between data structures and algorithms. So in an interview, like most of the recruiters, wants to find a candidate who can apply the right set of tools to solve the given problem. Now question comes to mind. Now I think this question is clear. Why data structure? Why people want data structure in interview? They would be never happen any interview without the data structure. Like if I talk about a good company like Google, Microsoft, Facebook, Amazon, these companies have higher package. Why? In these companies, basically, coding is just like an implementation. They roughly take 30 to 40% time to allot to give the coding. Most of the time, what they are doing, like we will see, we will take one more screen, and here you can see two part of implementation, two part of a software. One is the coding and another one is designing. Okay, this designing part is very, very important. You can say if I'll scale out of 10, 40% time it will take and 60% time it will take. Most of the time goes into the designing things. We want best and optimal algorithms. Why? Because it saves time, resources of a company, and obviously money. Money is more important. So the companies, core companies, if I talk about the core companies like Google, Yahoo, Facebook, Amazon, they only hire the candidates who can optimize their software as per user demand. Basically, it's not up to like if you know coding or not. But if you know the designing part, if you know the algorithms, you know the things, then you will get the good package. At the time of interview, they not even only choose the coding part. They will see the implementation, designing part also. Okay? So that's why data structures is very, very important. Are you guys getting? Can you give me a quick yes in chat window so that I can get your mind level also. You are getting the things, all the things are clear to up to you, up to this class, all the things are clear to you or not. If you have any question till this topic, you can ask me. I'm giving you the 5 minutes. And in this 5 minutes time, I'll address your questions. If you have any type of question related to data structures, you can ask me. Okay, I'm getting lots of yes. Yeah, it's giving me the positive energy. Okay, guys. And if anybody have some question, you can ask me. Design part, I didn't get it. Ansari Muhammad is asking a question. Design part is, Muhammad is like this. You will get a problem in your organization. You will get a problem and then you need to analyze the problem, like what type of resource I need to use, what type of data structure I need to use, and what type of algorithm I need to use so that it will give me more user-friendly solution with less resources, less time and less money. Are you clear now, Mohammed? Okay, and relation between data structures and algorithm, it should be clear. Shukesh. Somebody can give this answer? Yes. Bubal is asking one more question. Can you explain analysis of algorithm? Obviously, I'll take this topic separately. Analysis of algorithm is a big topic. Soon we will take this topic, and then I'll explain each and everything, like different type of complexities, different type of cases, best case, worst case, average cases, and how to consider these analysis of algorithm. I'll take a separate class for this. And I'm taking one by one questions, don't worry. Can you explain if all the languages have same data structure, then why we are different data structure, like C with DS, Python with data structures? Anurag is asking, it's not a different. All language implementation part is different, data structure is same. We are implementing stack data structure either in C, either in Python, either in Java. The concept of stack is same, and where we can use the stack, that is remains the same. You can implement in the different language as per your choice. Okay, next question I got, can we go through real-time implementation of data structures? Obviously, we will go through the real-time of implementation of data structure. We will do the implementation of different algorithms and different problems. And Priyam Patel is asking, does Python is acceptable in interviews? Yes, Priyam, Python is acceptable in interview. Interviewer never focus on the language. They focus on the concept, how you are solving a problem. They will see your way of approaching a problem. If you solve a particular problem in a particular language, it is okay with them. Rohan is asking a question. I have read Python is not that good at export level. Sometimes C or Java is better option than Python. It is not like that. You cannot say every language have some merits and demerits, but you cannot write like this. Python is not good at expert level. You can implement data science in the Python. There are the lots of work is going on in the Python. So it's not like this. Every language have their merits and demerits. Okay? Yes, I'll provide the questions in after every class. Don't worry. If you like this class, you can hit the like button also. It's C++ better than Python in data science? No. C++ are not better than the Python in data science. For the data science, I can say Python is better than other languages. Okay? Yeah, speed matters. Speed depends on the different algorithms, like what you are using, what you are not using. So it depends on this. Speed thing we will see, it also depends. For the speed, we will see the analysis of algorithm. Okay? Sometimes Python is little bit slow than the Java, the language. Depends on the what type of implementation you are doing. Okay, now I'll take a small topic, that is the abstract data type. A small topic that we will cover in next 10 to 15 minutes. That is the ADTs, abstract data type. So I'll open the new, and here ADTs. Full form is abstract data type. What is abstract data type? Okay. Data structures definition you already know. It is basically a way of storing the data so that we can access the data efficiently. Okay, so data structures I already covered, a way of storing data in memory. When I'm talking about the memory, I'm talking about the RAM. Way of storing in memory for efficient access. Okay, there are the two ways for looking at data structures. One is the logical way and another one is the implementation. Logical way, logical, or you can say abstract way. And another one is implementation. Okay. So basically data structure is a way of storing the data. I can say what is the storage means? It have certain rules. It have certain protocols can be followed. All the rules and protocols comes under the logical or abstract view. Here I can write like this: rules or protocols. Rules and protocols for storing the data. Okay, and second thing is implementation. Okay, implementation using programming language. Okay guys, now come to our topic, that is the ADTs. What is the abstract data types? Abstract data types are entities that are the definition of data and operations but don't have implementation details. It have data and operations. But don't have implementation details. Are you getting the things? Data structures we can see by two ways. One is the logical or abstract way, another one implementation. Logical way, you know the rules and protocols for storing the data, and implementation part is programming languages. So if I talk about the ADTs, ADTs are the entities that are the definitions of data and operations, but they don't have implementation details. Okay? So basically, I can take a real life example also here. Like you have your smartphone, right? I'll make the draw. I'll open a new file. And here I have my smartphone. Okay? And this smartphone has two things. Okay, one is the logical view and another one is implementation view. So you can say logical view, or you can say abstract view, and another one is implementation. Okay, in the logical view, what we have in your mobile, in your smartphone, this is our smartphone. Okay, in the smartphone, in the abstract view, what you have in your phone, you can think about it. You have a processor, you have RAM, you have LCD screen, you have camera, you have software, that is the Android or iOS, whatever you have. So if I talk about the abstract view, I have RAM, I have processor like Snapdragon, whatever you have, processor, and I have camera, screen, okay, or software inside a phone. One thing, and second thing, these are the data. You can say these are your entities. And now you have a process, what work you can do with your mobile. So you can call your friend, you can chat with your friends, message, or you can click the pics of your friends, you can take the images, and you can save the videos also, right? These tasks you can do with your mobile phone, and these are the things you have. This is the abstract view. And if I talk about the implementation part, implementation you can do either like you can write the code class A, and then inside the class there is the certain lines of code. That is the implementation part, and you do not know about the implementation part. So this is the real world example. If I talk about the data structures, then I'll again show you the abstract view and implementation part. Okay, so this is the simple thing. This is the example of abstract view and implementation view of real world. Now I'll take the example of data structures. Data structures. If I talk about the data structures, what is the abstract view and what is the implementation view? Like I can take a simple example of array. I can take 3-4 elements inside this array, like 1, 10, 20, 30, and 40. This is the data structure. This is the simple array. Okay, this array have different things. This array have these values. These are the basically values. Okay, and similarly we have index, we have memory address also. So if I'll write here the memory address like 2000 and 2004, 2008 and 2012, basically these are the memory locations. Memory locations are arrays stored contiguous. It's not continuous, contiguous, because every integer have 4 bytes. In most of the languages we have 4 bytes for the integer. So these are the memory address, and we have index also. Index like this, we have, if we want to access first element, then what we will do, we will write the index here 0, 1, 2, 3. These are the index. When I talk about the abstract view, what I have set of elements of integer type. I can read the elements by position, I can modify the elements. But when I talk about the implementation part, I need to write the code in the different languages. Okay, it basically depends on the language part and how or you can say how the actual implementation is going on. I don't know. I know the process, what I can do with the data structure, and what things I have in a data structure. So basically abstract data types only mention what operation to be performed, but don't know how these operations will be implemented. So here the abstract view, abstract or implementation. In the abstract we have certain actions, like add element, access element, and here the language implementation. Okay, so now you should clear with this. In the abstract data type, we have only operations. We don't know how to perform these, how to implement these operations. It doesn't specify how data will be organized in the memory and what algorithm will be used for implementing the operations. That's why it is called the abstract. It gives the abstract view, implementation independent view. Okay, guys. Now I think you should clear with the abstract data types. Now I can conclude the session what we have covered till now. In this session, we have covered what is the data structure, what is the algorithms, and how data structures and algorithms are related to each other, why data structures so in demand, and what are the abstract data types, and how we will do the implementation. We are going to do the implementation in the Python. Okay, guys, if you have any question related to till now the topic, you can ask in this session, and you guys can revise the session after the class. Also, you can listen the recording, and for the next class you can prepare yourself. These basic things we will use in the further sessions, like what is the data structure. These concepts should clear. If somebody asking you the question, what is the data structure, what is the algorithm, how they are related, how they are working with each other, you should know these things. Then only we can do the, if you know the implementation in the linked list but you do not know what is the linked list, how linked list working, then it is useless, obviously. So it is, I can say, a good programmer, you want to become a good programmer, you should know the knowledge of data structures. Okay, and for your any query, like any question you have, you can ask in our community, in the LinkedIn community. I'm there, I will give you an answer, and you guys can also share your knowledge with each other. Okay, so if you have any question, I can give you 2 minutes time. You guys can ask me the question. Otherwise, our team will help you regarding the queries related to your course certificate and whatever else you have. They will help you. Okay, and for the technical question, like if you have any doubt, in the tomorrow session also we will give you some time. You guys can ask your queries. Okay, guys. Abstract data types. Vatsal is asking, can you summarize the abstract data type? Abstract data type is basically, Vatsal, you can say these are only define what operation to be performed, but don't know how these operation will be implemented. Like I can give you the another example for ADT. Like you take an example of a stack. Like stack might include operations such as initialization, pushing data, popping data, destroying data, checking to see if stack is full, stack is empty. Like these operations we know, but here we don't know the implementation. Implementation may vary according to the language. Okay, I think now you should clear with this. And for the Python, if you guys don't know about the Python anything, you can join the next class. In the next class, I'll cover each and everything in the Python. Okay, and connected with our community, I will be always there. So you guys can connect with me. Even you guys can connect with me on the LinkedIn also. Okay, so first connect with our community. I'll give you the LinkedIn profile also. Don't worry about these things. I'll suggest, I'll give you the links for the study also. We will give you the lecture notes. Even you got in the chat also till now we have provided, and in the video description also you will got the lecture notes link. Okay, guys, I think enough for today. Okay. Okay, then thank you so much and see you next time. Okay, bye bye.